honor for me to introduce the keynote speaker. He's representing IBM at the Java Community Process Executive Committee, and he is a Red Hatter at the Jakarta Working Group. He's in MicroProfile. He's JBoss and VP of Engineering at Red Hat. Please welcome Mark Little.
Thank you very much. So I was just actually saying a minute ago that I'm going to give this keynote. I was asked if I would give this keynote quite a while ago. Came up with the title and then wrote it. And then I came yesterday to EclipseCon, sat through a number of sessions. I thought, I'm just going to be telling you everything you've already heard by the various presenters who've been here for the past day and a bit. But hopefully I can give you a little bit extra flavor to some of the things that you may have already heard. So, as you just heard, I'm VP of Engineering at Red Hat. We recently got acquired by another tech company you may have heard of called IBM, but we're hopefully not going to let that get in the way of anything. Just to give you a quick overview of who I am, in case you didn't know, I've been, for my sins, around in the middleware space for a long time, probably longer than, well, definitely longer than I care to imagine, and probably longer than a number of people I work with would care to admit to. Worked on a number of systems, research and industrial, including Arduino and Argus and ISIS, DCE and Corba. Still one of the best distributed systems in the world. If anybody's not used Corba, you don't know what you're missing out on. I did also implement the world's first 100% pure Java transaction service. This was actually even before there was a JTA. I've been active in a number of different standards bodies over the years. Anybody wants to kill me afterwards for co-authoring a number of the WS star specifications, you're going to have to get in line. I'm also a visiting professor at Newcastle University, where I did my undergraduate and PhD, and at Lyon as well. Been in the industry for a number of years, a number of startups. Got acquired by a company called Bluestone Software, who probably nobody in this room has ever heard of. All right, apart from Mike. Was a distinguished engineer there. They got acquired by HP back when HP kind of knew what they were doing in the software space. There's nobody from HP here, is there? Good. Didn't think there would be these days. And I was a distinguished engineer there. Became the CTO of JBoss in 2009 when Sasha Labore stepped down and I took over. And the last bullet is the one that really pains me as a kind of frustrated engineer. These days I spend far too much of my time on conference calls, working in spreadsheets and other things. And maybe one day I'll get back to coding. So, what are we going to talk about? What are you going to hear again if you went to some of the sessions yesterday? Really, we're going to look at why Java is still a key language, or should still be a key language in the cloud-native and Kubernetes world. Hopefully, most people in this room are Java programmers in one way or another. I know Eclipse appeals to other languages as well. But you're here, I think, mostly for Java or one of the JVM languages. If you've been in the industry long enough, you've probably heard every now and then that Java is dead, whether it's from analysts or from other people who come up with great new languages. Java's dead. If you didn't know that, it's not dead, and hopefully I'll prove that to you. But it has had to evolve, and I'm not just going to show you how it's had to evolve at the language level, but I'm also going to talk about how things have had to evolve at the framework and the stack level. Because Kubernetes, which is pretty much the de facto standard now for Linux container orchestration, imposes some changes in mindset through technological and architectural changes that really require us to think differently in the Java community. And then I'm going to lead into Eclipse MicroProfile, which was in the title, it still is in here, and it is a key area of this, like moving towards more Kube-native stacks. At the end, I'm going to touch on something which is not part of the Eclipse Foundation at the moment, maybe, who knows, which is something called Quarkus. Some of you may or may not have heard of that. It builds on MicroProfile. It's one of Red Hat's MicroProfile implementations. I suppose I should say it's one of IBM's MicroProfile implementations now. But it's also pushing the boundaries beyond what MicroProfile itself is doing, and I want to tell you a little bit why we thought we had to do that, even when we had a couple of other MicroProfile implementations at the time. All right, so why is Java still important? It is still the de facto language for enterprise deployments. Doesn't matter whether you go to TOB or wherever, you'll see Java is like number 1 and number 2 constantly for the last decade. Back-end developers tend to, by default, look at Java. I know there are some popular languages coming up. A little one called JavaScript. There's one called Rust. But at the end of the day, most deployments are being done on Java. There's a huge skill base. 7 to 10 million is up here. I've seen figures close to 14 million. It's really hard to actually know what the real figure is, but we'll make these slides available hopefully afterwards, but there are some links there where you can at least see where I've got these figures from. And importantly, it's a large, diverse ecosystem. It's not something, despite what you might think, that is dominated by a single vendor. You've got IBM, you've got Red Hat, you've got Fujitsu, you've got Netflix, Pivotal. All these companies and more are driving the evolution of Java and have been for a long, long time, which builds on the fact that it makes it a very resilient community. As I said, Java has been declared dead more times than I care to remember, but it keeps coming back and evolving and taking on board, new requirements, whether it's how to work better in a Linux container or, how to actually be able to write complex code with annotations instead of having to get in there and actually write lines of code yourself. It's extremely resilient at the language level and at the framework level. And this next point, I'm probably as much to blame about this as anybody I know in the Java community, but whenever we hear about, Rust is better than Java, and I'm not picking on Rust, it's just I know that there was Jens from Red Hat was presenting on Rust earlier. But whenever we hear that language X is better than Java, we as a community tend to come back and talk about the language when really we should not be thinking about the language. We have a huge ecosystem that has built up over the last 2 decades around Java that is, at this point, I'll say it's incomparable with anything else that's there in a positive way. It doesn't matter whether there's a great language that comes up with a different signature that just happens to be a little bit cooler than the method signature that Java has. If that language does not come with all the IDEs and the CIDC systems and the equivalents of Maven and all of the third-party libraries that have been built up literally over the last 2 decades, then it can negatively impact developer productivity. If you're an ardent Java fan or you want to try to be objective about Java versus another language, don't just think about the language. Think about everything else you take for granted that makes you productive as a developer, because those are the things that really are very, very hard to duplicate, and I'd say impossible to duplicate in much less time than it's taken us to do them in the Java community. But also importantly, the innovation in Java at the language and the stack framework level is continuing. You've heard a lot about MicroProfile. Like it or not, you're going to hear a little bit more in the next few minutes. There's Jakarta EE as well. The move by the OpenJDK community to have much faster release cadences for Java SE is another example of how we're listening and to the feedback and trying to push innovation. And then things like Graal VM and Substrate VM. This is not meant to be a complete list, but just put a few bullets on there. So to get to MicroProfile, I want to give you a little bit of a historical background to what drove us to do that. And some of you may or may not know most of this, but if you go back to the late 90s, early 2000s, when J2E was really starting to take off and then evolve it forward a little bit, this is your typical enterprise Java stack. You had the operating system. In fact, you still have the operating system. And you got your JVM, whether that's Hotspot or J9 or something else. Then you have your application server. And then you got your frameworks that sit on top of that, Spring Framework, Spring Boot, CDI would definitely be one of those. And then you've got your apps that sit on top of that. Now, we always talked about having multiple apps running in the application server. That rarely happens for a number of reasons, but one of which is kind of fault tolerance. The JVM itself is a single unit of failure. It's not multi-tenant aware. Well, I know there are some versions that can be, but historically it's never been multi-tenant aware or red zone protected. So the crash of a thread in a JVM could take down the entire JVM. So running more than one app was a risk. Running related apps, that's fine. If you want them to fail as a unit, stick them in the same application server on the same JVM. But this is essentially the stack that built up. And it's worth looking at some of the words down the left-hand side as you see it. Yes, it is the left-hand side. When Java evolved, it evolved in a period of time where other languages that were around were C, C++, still some COBOL. I mean, there's still COBOL today. Pascal, those sort of things. And the applications that were being developed were generally designed to be extremely long-lived. You would fire them up and you would walk away and you would hope, and probably be okay to do that they would still be running days, weeks, months, and potentially years later. So a lot of work went into optimizing the application server and the JVM for these long-running workloads. To the point that today, if you're running Hotspot or J9 or other JVMs are available, you can get performance on par with, if not better than, C and C++ and compiled. But you have to run them for long durations. You have to let the JIT kick in, for instance. But that was the environment in which the JVM grew up, and the environment also that application servers grew up in. But then along came microservices. Whether you like them or not, whether you think they are SOA done right or REST in a nutshell, microservices came along 7 years or so ago and really changed the shape of the landscape that developers were working in. I don't want to say too much more about microservices, although I will put this slide up simply because I don't think microservices are a silver bullet. Just like SOA was never a silver bullet. There are pros and cons of them. One of the big things about microservices that we tend to ignore, although we're getting much, much better at it these days, and MicroProfile is helping there, is that microservices push us back to a true distributed system. One of the areas that J2E and Java-E and even .NET to a degree kind of moved us away from was very, very distributed systems. We were really talking about 3-tier, and those tiers tended to be very close together. But with microservices, when you're talking about tens, hundreds, and in some cases thousands of individual services, it becomes harder and harder to think of these things as semi-co-located efforts that if they're going to crash, it's easy enough to debug. Debugging a local application server is hard enough. Debugging a distributed system, even a one based on Java-E, can be harder. Debugging microservices without things like tracing involved is very, very hard. So, I put these up here simply because, like I said, no such thing as a silver bullet. Microservices are very, very complex things. Enter into them very, very carefully. And I don't believe monoliths are evil, okay? If you've got a good monolith, great, embrace it, make friends with it. If it's been running your business for the last 20 years, it's your best friend, and keep it like that. So once we had microservices, then quite closely after that, we saw the advent of Linux containers, which had been around for a while, actually, before they were popularized by Docker. And if you've been running other operating systems like Solaris, for instance, the equivalent has been in Solaris for a lot longer. And then after we had Linux containers, along came Kubernetes. Open source project, as I said earlier, pretty much the de facto standard now for container orchestration in public, private, and hybrid clouds. A number of implementations are out there. I put OpenShift up here because, well, I work for Red Hat. Oh, damn, I work for IBM, and that's now our combined Kubernetes distribution, but like I said, there are other versions up there available, sorry. The last bullet, though, is kind of the key point that I want to hammer on a little bit in the next few slides, is Kubernetes assumes an immutable architecture. Linux containers don't require you to make them immutable. If anybody's used Linux containers, you'll know that if you spin something up and you make some state changes and you exit it, you can go back and you can recreate that same image and pick up from where you left off. Kube does not allow you to do that. It assumes that the container images it spins up from its repository are stateless, so that it can manage workloads and failovers very quickly. Distributed state change and handling it in a very large distributed system is extremely complex. Doing it in a way that guarantees consistency and reliability is very, very hard as well. I refer back to what I said earlier about transaction services. If you've got state in Kubernetes, it assumes that it is off that Linux container through something like persistent volumes is typical, where you would mount a file system that's being maintained somewhere else. But like I said, it pretty much does require that if you have an image in its repository that it's going to spin up, that if you make state changes to that, they're going to get lost the next time it requires to spin up another image or another copy of that image from the same repository. Going back to what I said earlier about the world in which Java grew up, when we looked at microservices and we're looking at Linux containers and then we're looking at Kubernetes, there started to become this notion of a Java problem. And it's probably no surprise that other languages like Rust and Golang and Swift, etc., started to become more popular in microservices environments because of this. So, as I said, Java was created in a world where you're looking for long-running applications. You spin up your JVM, and it grabs all the memory that it needs, and it doesn't release that because it's probably the only thing that's going to be running on that machine, and nothing else needs the memory. It optimizes over time because, again, it's kind of long-running. It's not optimized, or wasn't optimized, back in the day for kind of startup speeds. And likewise, the frameworks and the stacks that ran on top of them didn't really have to be optimized for startup speeds. Because if it took 5 minutes to spin up the JVM and the application server to then start doing some work, who cares if that application server is then going to be running for 365 days continuously after that? That 5 minutes basically is a rounding error in its availability. Now, that's not to say that even before the cloud, as a community, we were not working on improving startup speeds. IBM with Liberty and Tommy Tribe with Tommy E and Wildfly. Lots of other application servers as well have been focusing on startup speeds for a long time. But generally, it was not seen as a bit of a problem area. And also, our frameworks and stacks built on some of the key areas that Java really distinguished itself with when it first came around. If you weren't there in like 95, you probably won't kind of get too much of the of how different Java was. But back then, like I said, C and C++ were the primary languages that people were developing in. Neither of them had threading involved in them. There was no thread support in a language back then, really. I remember writing my own thread packages for C and C++ using set jump and long jump. Java comes along and they're built in. Fantastic. Memory management was a lot easier in Java than it was in C and C++. Also, Java allowed you to be a hell of a lot more dynamic. You could do lazy binding. You could spin up an instance and not bind the interface to the implementation until hours, days, weeks later on. And we've kind of built all of our frameworks and stacks on that because it's part of the language. We've optimized our application servers, for instance, so that we don't have to take them down when we want to send them a new implementation of a service. I can just send it a new set of classes, and it'll notice, hopefully, that the state has changed on disk and spin them up, load them through the class loader, and make them available. And you haven't had to have a break in service at all because you haven't had to take down your application server. So all of these stacks and frameworks have built up to use that because it's part of the language. It's a natural thing for us to do. But unfortunately, in a Kube world, it's not something that you actually would do. Now, Java is trying to pivot. It's been trying to pivot for a while. It's things like JPMS, aka Jigsaw, to try and slim down the size of the JVM. Ahead-of-time compilation, Graal, as we'll come to later on, to change the way in which the JVM is architected. But I actually argue, and hopefully as you'll see later on with Quarkus, that if you only change the JVM, you don't get the benefits of all of the things that you could potentially do if you optimize also and re-architected your projects that sit above it, your frameworks and your stacks. So this is kind of the typical thing that we were seeing back when the Java problem started to really become a problem, and people were literally certainly talking to Red Hat project leads and to customers and say, we're being told we have to now go to Node or to Go, because in the cloud area where memory footprint is really important, it's costing me an arm and a leg to do this on Java, and I can do the equivalent in Go or Node.js for a lot less. So we absolutely needed to do something about this. It's like I said, memory footprint in the cloud is extremely important. Yes, you do pay for your CPUs as well. If you go to Amazon, you can get to choose the type of processor that you're going to pay for. But typically, it's the memory footprint that will kill you in terms of your bill. So optimizing for that is critically important in whatever we were doing from a cloud-native perspective. And if you think about the amount of heap space that a JVM would normally consume, and try and scale that to microservices, where you might go from 1 JVM to 20 JVMs, that becomes a headache. Try and scale that from 20 JVMs to 200 if you're doing serverless, it's almost unmanageable. And from a Red Hat point of view, when we were thinking about MicroProfile and then getting involved with the likes of IBM and PyR and others, we really believed that Java was the right language, still the right language for the cloud. But if we didn't do anything to prove it and tune it and make it better, we were eventually going to lose to other languages. And I'm not against replacing one language with another where it makes sense. I kind of did that moving from C++ to Java back in the late 90s, and many of the industry did. But I don't think that Java is in the same position that C++ was back then. I think there are certainly a lot more things that we can do to continue for it to be that #1 language. Because this is essentially what we want to try and get to. We want to break down the monolith to microservices and then to functions and make it absolutely clear that in every single one of those boxes, you can have Java. You can think about choosing Java as your first language and not worry about somebody saying, but how does it compare to Golang, for instance? So this all leads back to, what were we doing, what were we thinking as a collective community back in 2015 when we were coming up with MicroProfile. We wanted a cloud-native stack. Kubernetes was kind of in the picture at the time, but it wasn't as popular as it is now. So I even think when we were having our first meetings, pardon me, with IBM and Tommy Tribe and others, we probably weren't even thinking about Kube, we were just thinking about, cloud, more generic. But what we want is a stack, and that includes the JVM, that is Kubernetes native. That can be used on raw Kubernetes, can be used with Istio, could be used to write operators if you're going in that direction, can use Knative for serverless. Not something that you have to have, a different stack per deployment. If you can have one that works well across the lot, then that's good from the developer point of view. It's also good from a vendor's perspective, and I mean that. Sorry, I don't mean that from a Red Hat or an IBM. I mean somebody who's buying this in to give to their developers, like a bank or whatever. Now, as I said, it all has to start with the JVM, though. And there have been a lot of efforts over the last few years on optimizing the language and the JVM so it runs better in Linux containers and with Kubernetes. There's been a number of efforts around memory utilization and processor utilization. Believe it or not, if you went back like 3 years and you span up OpenJDK, I can't say if this was the case for J9, I just know it was the case for OpenJDK, it would still grab all the memory regardless of what you said the container was allowed to have, and it couldn't tell you how many processors were running because it had grabbed them all as well. So that's been changed. Work that is going on in OpenJDK around better garbage collectors like Shenandoah. OpenJ9 or Eclipse OpenJ9 with the JIT as a service. All of this is intended to make Java better in the language and the JVM better in the cloud. But then there's things like compile Java. So GCJ, probably nobody in this room apart from people who are from Red Hat might have heard of this, but GCJ predates OpenJDK. It was essentially a compiled Java. It was started by a guy called Andrew Haley, who is the Red Hat OpenJDK lead. And it, as its name implies, it was an attempt to do compiled Java up to, I think, probably version 1.4. Just shows you how old it is. But I put that there because there's a lot of work been going on in compiled Java for a long, long time, even predating the cloud. If any of you have ever looked into what goes on an Android phone with Dalvik, and maybe some court case between Google and Oracle, that may or may not still be going on, they essentially did this as well. Dalvik, based on a subset of Java that they compiled. Then there was an effort called Avian, and there was a company called Excelsior Jet who had, or Excelsior, who had a product called Excelsior Jet. Again, they were doing compiled Java. And now we've got something from Oracle Labs called Graal VM. All of this kind of points to a common problem area that people have in the back of their mind, that perhaps build once and run anywhere is great for certain types of applications, but maybe you do want to go down to native, again, for certain things, and maybe functions as a service is one of them. But like I said, JVM improvements are absolutely critical. They go hand in hand with the improvements that we're looking at from a microprofile point of view and further on than that. So also at the same time, because Kubernetes was on the rise, but cloud, hybrid cloud as well, was starting to incorporate key capabilities in it, like security and messaging, things that you would essentially just take for granted in your cloud infrastructure. We were starting to see application server vendors and also some users question whether they needed to bundle these things in the app server in the first place. If I've got a really good transaction service that the cloud provider is giving me, do I need to bundle my own? And is it even cost effective to do that? So we, certainly from Red Hat, and I'm going to assume from other vendors, we were starting to look at breaking apart our application server, making some of these capabilities, if they weren't already a part of Kubernetes, a part of OpenShift, and hence a part of Kubernetes. So you would have essentially, you'd have like a virtualized application server that was running on the cloud. It might look to your application, whether it's an EJB or just traditional or just POJOs, as if it was still deployed into an app server. But it, underneath the covers, the transaction service was over here in a different pod, and the messaging service was over there on another one, and the database was elsewhere. So we were already seeing people break apart your application server. And like I say, all of this kind of fed into Eclipse MicroProfile. We decided that these capabilities, whether it's messaging, transactions, security, caching, and frameworks, you need them in the cloud just as much as you needed them out of the cloud. Now, perhaps some of them are provided by the cloud vendors, and we have to work with that rather than try and duplicate that. But maybe, certainly from a microservices point of view, maybe we don't need everything that's in a traditional application server, and maybe we shouldn't be requiring everybody to come to the table when they're building microservices with this Java EE mentality. There's a huge raft of and wealth of specifications and implementations in Java EE that we absolutely do want to make available to developers of microservices, but we don't want them to have to take it all in one go. And also, by that point, there was this perception, and I say it's a perception because it really wasn't reality by 2015, that Java EE was bloated and that the application servers that were implementing it were bloated. Like I said, that wasn't the case then. It's certainly not the case now. You can have application servers that are really, really small and that spin up in a couple of seconds. But the perception was there, and when people are being told by their bosses to go for other languages, 9 times out of 10, they were also being told because Java is not a language fit for the cloud, and because your favorite application server is way too bloated. So coming at this from the point of view of, we're going to leverage the good bits of Java EE, but we're not going to require you to have to do all of Java EE, but we're also going to leverage what's going on in other communities like Netflix OSS, I think gave us the benefit of, in some ways, having a clean slate, but not having to reinvent the entire wheel. So when we announced MicroProfile in 2016, there were a number of, well, there weren't as many logos there at that point. There was IBM, Red Hat, Pyara, Tommy Tribe, London Java User Group, and I think SueJava. It's grown a lot since then, and the number of implementations has also grown a lot. And if you look at that box there to see the specs that are in MicroProfile, and I will go into this in a little bit more in a minute, you can see that in the 3 years since we announced it and then moved it to the Eclipse Foundation, we've made some significant progress. 9 releases in 3 years. Again, if you are in the JCP, if you've been involved with Java EE or J2E even before, 9 releases in 3 years is unheard of. The closest we're getting to that now is probably in OpenJDK, because we've now moved to 6-month release schedules. But still, 9 releases is significant. And that's not a vendor-driven thing. Hopefully, you can see by those logos, by those implementations, and if you go to the various mailing lists, there's a huge number of people who aren't members of the traditional vendors who are contributing to MicroProfile. I should also point out that MicroProfile was a Duke's Choice Award winner last year. So another nice thing for the MicroProfile community to remember, and hopefully we'll be a Duke's Choice Award winner again. Here's another pictorial representation of the progress that we've made, building on that box early, but to give you an idea of how we've evolved the specifications as well. So MicroProfile 1, when we came out with it, was 3 specs. It was literally just 3 specs: JAX-RS, CDI, and JSON-P. We decided they were the base layer if you were going to build microservices, and anything else, we could argue about it, but we would never get agreement at that point. We'll argue about it in the community, so let's just start from a base and build up. Since 2016, we've made huge 9 releases, a lot of different versions of each of the specs. Fault tolerance, it built on, a lot of work, but particularly the work that was going on by Netflix. Open tracing and open API. I know that a number of presenters have talked about these, today and yesterday. So, well done to the community. And this is kind of going a bit more into that box that you saw 2 slides ago, but this is what's projected for 3.1 this month. So the boxes in blue are updated specifications. The ones at the side are what we're calling at the moment standalone. So they're ones that aren't part of a main MicroProfile release. They're deemed to be useful for some microservices use cases, but perhaps not useful for all of them. What we're trying to do at the moment is make sure that if you download Eclipse 3.0, for instance, or 3.1, or you download an implementation based on that, everything that's there is pretty much going to be what you will want to build microservices. There's still some debate about whether everybody wants reactive messaging or context propagation. I think we need to, as a community, figure out that answer, because having things to the side is a little bit strange and maybe confuses the message a little bit. But again, I'm not putting that up there to debate that. I'm just putting it up there to give you an example of where we started with 3 specs to where we are now. And again, I'm not trying to knock Java EE, but if you consider how revolutionary Java EE has been over the last decade and compare and contrast it with how revolutionary I think MicroProfile has been, it's, the scales would fall further down on MicroProfile being revolutionary in general, and absolutely for cloud. And then we've got a number of other things that are still on the roadmap. So we've got long-running actions, which is my favorite because it's transactions and it's based on some work that I did with IBM and others in Oasis about 15 years ago, called WSCAF. Where we're doing some work on GraphQL and reactive relational databases. So it's great if you have reactive system, but if you're the more non-reactive and blocking components you have in that, then the less you can utilize reactive. So databases are still very, very popular, and we want to make sure that by working with some vendors and some open source communities, we can actually push them in a reactive way. Event-driven microservices, depends on who you ask, but I personally think event-driven microservices and event-driven data is pretty critical for the evolution of microservices. Service mesh, so that's like Istio, for instance. And then there's a new thing called start.microprofile.io, which you could go to now, and you can start to build a microprofile application. And again, this is all community-driven. Now, there might be a bit of an elephant in the room here, and it's called Jakarta EE. I know, unfortunately, I wasn't able to get to the meeting on Tuesday night where there was a discussion about Jakarta EE versus microprofile. I don't want to reopen that discussion. I just want to say, if anybody wants to ask me questions about this later on, you can do. Just don't ask me any questions about Brexit. I can take hard questions. I just can't take impossible questions. My opinion on Jakarta EE microprofile is on record, and it remains the same as it is now. Microprofile is rapidly innovating, and Jakarta EE has just got going. I think at some point these things need to come together in some way. I'm not going to be pushed on what I mean by come together. They absolutely are influencing each other today. Jakarta EE has some specs that we absolutely want to take into microprofile and vice versa. How do we do that in a coherent way? We do need to sort it out, and I know that there are discussions going on, and it will get sorted out. Before I get on to the next step of a Kubernetes stack, I did want to call out one other Eclipse project. So I've talked about microprofile, I've talked about Jakarta EE, I've talked about J9, all great Eclipse projects and efforts. The other one is Vertex. If anybody's not using Vertex and you're using Node.js, stop and go and use Vertex. If you're into reactive, asynchronous, event-driven systems, and you're not using Vertex, stop and go and use Vertex. Vertex has been around for a long time. If you know Node, or you know that pattern, it's very similar to that. In fact, when it was started by a guy who used to be the project lead for the JBoss Hornet Queue effort, it was called Node.x, because he wanted to do Node for Polyglot. Apparently the Node people didn't like that, so they asked him to change the name, so he changed it to Vertex. But it's a very similar model. It is polyglot as well, so it runs on the JVM. So if you really want to write JavaScript, you could write JavaScript on the JVM, and you could use Vertex. Or you could do it in Scala and Java and all those nice languages. And it was a 2014 JAX Innovation Award winner. This is just a list of some of the companies that are using Vertex. If you're not using it at the moment, you can find this by going to the Vertex website. But it's been around for a number of years. It's used in anger, and I don't mean that in a negative way. I mean that people are really using it. And I think it's a critical piece for this cloud-native infrastructure because, as I said earlier, I think event-driven microservices are the future. Everything we do is event-driven in one way or another. We react to stimulus. It makes sense that our microservices will react to stimulus themselves rather than being kind of static and synchronous. So Vertex is critical, and I think the reason I mention it as well is that Vertex is also used in Quarkus. So Quarkus is an effort that we publicly announced back in March this year. It had actually been going on for about a year before that, and we just didn't want to make it available because we didn't think it was quite ready at that point. It was originally called, let me get this right, because I came up with the name, and I'm really good with names. It was called That Which Comes After Java EE, but is not. That Which Comes After EAP, but is not Java EE. I got that right, didn't I, Dimitri? It was a bit too long. You couldn't put that on T-shirts. Then it was called Thornfly.x, and eventually it got called Protean. I still like it as Protean, but we couldn't get Protean through our legal team, so then it got called Quarkus. Because the team like subatomic particles, and they think they're physicists. They're not. What we did, though, in Quarkus goes back many slides to when I said that optimizing the JVM is important, and it's a necessary condition, but it's not a sufficient condition. If you want to have a kube-native infrastructure, you need to recognize the things that I mentioned earlier, that we've been programmed for the last 20 years to think Java is a dynamic language. We want to start these things up, these JVMs and these application servers, and we want to leave them running for a long, long time. So not only are they optimized, but there's no downtime. So we leave evaluation of interface implementation binding until very, very late. We even optimize for reflection, or and have class loaders all over the place. Yes, OSGI, I am looking at you. Sorry about that. But in a Kube native environment, you don't need any of this. If you're going to change your application server runtime, you literally go and spin up, generate a new Linux container, stick it in the Kube repository, and it will fire it up next time. And you can do that in seconds. And it's getting faster and faster. If you try and do that within your application server, as it's running in your Linux container, it'll still work, but when Kube decides to take that instance down and spin it up somewhere else, you're going to have to start from scratch and rebuild it and build it up to where it was going before Kubernetes took down the previous instance. None of that stuff is persistent. So like I said, what we decided when we were thinking about how can we optimize for Kubernetes was not just at the JVM level, it was to go back and look at what we've been doing for years in our projects and our products. And it was to think, you know what, let's do as much as we possibly can at build time. Let's actually make these decisions about what implementation am I really going to use for this messaging service at the point I say compile, and not 7 days later when I still had the same data when I started the instance, but I'm not going to do it until 7 days for some reason. Optimize all of this stuff away from runtime to startup time. And also, this gives us the ability to remove dead code, because if you are going to be doing lazy evaluation and lazy binding, you have to ship all of that code with your project, with your application. If you leave it to runtime, you basically have to ship all the code that can possibly ever be used by any path that your code may go through. Whereas if you make it as a build time optimization, we're forcing you to make that decision at build time, but as a result, you're also not having to ship 101 different class files that you're never going to use anymore. So building all this and optimizing it for the build time and deployment time rather than runtime was a key thing that we did within Quarkus, and it's something that I think we will, as you'll see in a minute, we will feed back into MicroProfile as well and elsewhere. So, but what about MicroProfile? Well, did I put it on this slide? No, I didn't. Okay, so as you'll see in a minute on the next slide as well, but Quarkus is a MicroProfile implementation. It's always our intention to have it as a MicroProfile implementation. It will never be a Jakarta E implementation. It will be a MicroProfile implementation. Because we all know the benefits of open standards. No vendor lock-in. And if for an open standard point of view, as we've seen with the fast evolution of MicroProfile, if you don't like something or you think there's something missing, you can come in and you can start to hack on it and make it better or even add it. That's how a number of the specifications, like LRA, for instance, have been created. Somebody came in and said, we've got this idea. What does other people think? Let's get together and let's try and hack out a spec and then some implementations. And MicroProfile in Quarkus, because of that, allows you, even if you're not thinking about Quarkus today, think about MicroProfile, because at some point, if you do decide you want to go the Quarkus route, you can kind of lift and shift your MicroProfile-based application and put it on Quarkus, and Quarkus will, and you can run it and get all the benefits, as you'll see, of Quarkus. And as I said, we want to make sure we feed all of the things that we're doing in Quarkus back to MicroProfile and other efforts, Jakarta E possibly, and OpenJDK as well, and maybe other areas. So I have mentioned Graal a little bit before. I'm going to put this up here now as well, because one of the things that has really got a lot of attention is Quarkus's use of Graal and specifically Substrate VM for compiling to native code. That is an important thing, but if there's one thing you walk away from this talk remembering, it's that it's not sufficient. We probably spent more time re-architecting the frameworks and the stacks that sit above the JVM than we did on Substrate. And doing that was where we got a significant amount of performance improvement. But it is still an important part of what we have with Quarkus, and we're continuing to use that. So there's a number of benefits that we get from Quarkus. I've already touched on a few of them. One that the team like to call it is developer joy. I refer you back to one of the first slides I had in there. I can't remember the last time I was a developer and I was joyful, but if I get off spreadsheets and Excel, I might get back to that. But based on standards, but not limited to that, what that means is we will follow MicroProfile, but we're not going to be constrained by MicroProfile. We're going to evolve it, and hopefully the MicroProfile will evolve based on our input. But we want to go beyond that, and that's kind of like what everybody's been doing in a way. All application server implementations went above and beyond what was defined in Java EE. We've gone for a unified configuration. In many ways, we used to have a unified configuration in the application server, but then we got people saying, well, you need to pull it out and have every single component have its own configuration file, and we've kind of gone full circle there. We've optimized Quarkus and our MicroProfile implementations, which are in it, which actually come from the SmallRye project. If nobody's heard of SmallRye, please take a look at SmallRye. But we've optimized it for the 80/20 case. You might think, well, that's pretty obvious, and in some ways it is, but Java developers in general, I have to say, hand on heart, JBoss developers specifically, we're always giving you 1,001 different ways that you could hang yourself. If there was 1,001 different ways to fix a problem, we would give you 1,002 different ways to actually fix that problem. Those 1,001 other ways are still there, but we kind of optimize for the 80/20 case. This is a prescriptive approach. You can go beyond that if you really want to, but really you should stick with a prescriptive approach, and we think that gives you far more benefits. Quarkus also unifies imperative and reactive programming. So Vertex is under the covers. If you want to write async reactive microservices with Quarkus, you can, and you're using Vertex. So we're not reinventing that wheel. We've brought Vertex in. But you don't have to, and Quarkus has a very nice imperative way of building microservices. And as I said, we've re-architected an awful lot of projects. This is not even a complete list. So just to give you an idea of some of the benefits that we've got from using MicroProfile with SmallRye and optimizing our frameworks and our stacks, we got some examples on the next few slides. So we've got a very basic Hello World application, and we've implemented that in 3 different ways. We've implemented it, well, 2 different ways. One with Quarkus, and one with a traditional cloud-native stack. So, that could be Thorntail, Wildfly, Spring Boot, whatever. And that's also running on OpenJDK Hotspot. The 2 different Quarkus ones, one is going the full end of the spectrum to actually compiling your application to native executable. The other one is just running on OpenJDK Hotspot. And as you can see, compiled, the memory utilization for this Hello World is only 13 megabytes. We do have a graph, which I keep forgetting to put on here, which compares this with Golang, and Go is around about 7 or 8, something like that, maybe a little bit more, but it's comparable. Then if you look at what we're just doing with OpenJDK Hotspot, so no compilation in there, just Hotspot that you could download from Adopt or somewhere else, still only 74 meg. That is because of the optimizations we did at the framework level and the implementation level. And then we've got your traditional cloud native, which is twice as big as the non-compiled Quarkus. Put some database access in there, so JPA, I can't remember what the database was for this, but the memory utilization goes up on the pure compiled version to 35 megs. Still not a huge amount of memory in the grand scheme of things, and not when you're thinking about running this in the cloud, and certainly not when you compare it with the traditional cloud native approach, which is 218 meg. In terms of boot time, and if you didn't see it, there are enough videos online where you can find it, but Dimitri, who's in the audience today, gave a session yesterday on Quarkus and illustrated this live. But boot time is the thing that people have really focused on because apparently it makes developers happy. The Hello World one, boots up with compiled in 0.014 seconds. It takes a little bit of time to do the compilation, but that's kind of like substrate magic. But once you've got there, you can boot this up very, very quickly. Even on OpenJDK, it boots up in less than a second. With the traditional cloud native stack, still 4.3 seconds. Not bad. Certainly not bad, but that's not in the ballpark for if you're doing functions as a service. If you want to react in real time to a message that comes in and says, scram the nuclear reactor, I guarantee you want to do it in a fraction of a second. Otherwise, you're never going to be able to get in your car and drive away before it goes critical. Even when we move to putting JPA in there, Quarkus compiled is still booting up in less than 1/10 of a second. So I'd still say that's pretty significant. So we have, if you remember that slide earlier about the traditional, current, modern, whatever you want to say, truth about Java, where you had only like 4 traditional cloud-native stacks on a node. We have moved the argument from using MicroProfile and using various optimization techniques to this, where Quarkus, like I said, MicroProfile as well, does now compete very well against other options that are out there. And in fact, at Code One this year, we had one of the program managers who was demonstrating this at a booth. He got like a 16 gig MacBook. He was demonstrating it for the course of the full day and forgot to take down each demo each time he did it. So at the end of the day, he had hundreds and hundreds of Quarkus instances running. I hadn't even noticed that they were running because they were taking up so little amount of memory. So in conclusion, I think I might have just gone over a little bit, but in conclusion, we have to think from a cloud native and a Kubernetes stack, we have to think differently. The problems we have today are not the problems that we had 10 years ago or 20 years ago. We have to recognize that there are environments like Kubernetes that really don't need a lot of the baggage that we've had built up within the language and the JVM and within the frameworks. And therefore, we can't expect the same solutions that we've been using very happily for the last decade or 2 decades to work as efficiently in cloud as they have worked prior to cloud. We've got to adapt to these changes, and we've got to understand what the different trade-offs are. I mean, even with Quarkus and with MicroProfile, you're making a trade-off, but you're making that trade-off on an informed decision. You could say, well, I'm making a trade-off, for instance, when I go to the compile from not being able to build once and run anywhere. And you're true in that regard, but if you think about it, pretty much, if you compile to Linux, Linux is pretty much the default everywhere anyway. In terms of the cloud, you can find a Linux distribution on all cloud providers, so you can still build once and run it on any cloud. MicroProfile is a great standardized way of trimming down your application server now to a way in which we can build enterprise microservices, but there's still a lot of more work to do in that area, and I showed you some of the things we're working on. I would hopefully inspire you to go and get involved if you're not already involved. And combined with changes that are going on in the Java space and in the stack space, I do think we have a huge opportunity to continue to evolve Java and continue to make it relevant in the cloud, whether that's hybrid, public, or private. Okay, with that is my last slide. Thank you very much. Anybody has any questions? I'll take them afterwards.